Thank you, Susie, for turning up to our training session today on the sound system at St James. We're going to go through some WHS issues the systems that's inherent in the system, go through an overview of the system, some of the elements, to do a plug-in practice, and then to talk about troubleshooting. And the idea is that you might be able to, it's been tailored so that you might be able to walk away and instruct or sort of guide people in the congregation to do their task when they've been allocated. If that's all okay. I'm your husband, David, and we've done our role. There's as part of this course, there's a learner conduct sheet which has your rights as a learner and also responsibilities associated with doing the course. This is supposed under the guise of doing the course that's under the creative arts, what they call it, stream, or the package, learner package, and it's actually just a portion of that particular module. I think it's called 211, so designing or implementing a sound system. You know the facilities better than I do because you're in charge, but you know that the emergency exit's over there. There's one over here with a panic bar, and to get out into the backyard, it's to open up. You're also aware of the incident reporting system, which is on the wall over yonder, and you are the responsible person. So we can move on from there. I want to go through first. I've got a PowerPoint presentation that goes through some of the key areas, and it's mainly just visuals. But first, these are three sort of, what would you call them, triggers to talk about three types of different hazards in the area. Do you know what this particular instrument is? Have you ever seen? It's got, what has it got here? It's got a test button. It's got some sort of power system with it. I might turn this around if I can. No, I can't. Can I do it that way? Yes. It's got a switch there. Have you ever seen one of these maybe in a power board? It's called a...
Oh, looks like a safety switch at the top.
That's exactly what it is. That's exactly what it is. A 10 amps safety switch. We have several of these in our system. It's called a residual current device. The system here has three wires. One's to the ground, one's positive, one's negative, and an alternating current power system triggers when there's a fluctuation in either the positive or the negative, and causes any fluctuations tested to about 40 milliseconds on that board over there and switches out. The reason why I mention this is because there's power running right through this sound system. So, you ever heard of phantom power? Mm-hmm. Yep, so do you know what that is? Or
I just know that's what we've got in our sound system.
That's right.
That's about all I know.
It's only 1 or 2 milliamps of power running across the floor, but every single cable, like that big fat cable, which I'll show you, the snake, has every channel activated for phantom power, and so the device at the end either accepts or rejects it. And yes, it's running 48 volts of direct current. So technically, anyone who puts their finger in between that cable, they might get a little bit of a zap if there's anything went untoward. It's unlikely. We have all the cables out of the way, so we keep the system in a workplace health and safety satisfactory condition. But that is what's going on right around here. There's power where it's activated. As you know, the power system's all centralised pretty much. There's a couple of exceptions. Sorry, there's a couple of exceptions which we'll talk about later on the stage. But yeah, that's particularly important. So if ever there is a loss of power to any of the air conditioners, for instance, do happen from time to time in the building, but also the power system, it's worth going and having a look at the board. And often it's just the case that there was a little bit of a fluctuation caused by some murmur outside the premises. Do you know what this one is?
I presume it's about decibels, how loud it is.
That's right. It's a decibel meter. Anyone can download. It's Decibel X app on the web. So I'm showing this because sound is our purpose here is to create a clarity of sound so people can hear the messages that need to be sent around the congregation. But what does this sort of indicate?
What does what?
Can you see some of the features of this particular decibel reader?
Well, showing what the decibels is. I don't know.
Okay. So that might indicate something inside a car is the level that and when I took this photo, this is when Gina was doing sound setup about 2 months ago. I just took a snapshot, and it's actually a really good representation. The figures here represent probably a little bit less than what the maximum sound should be at any particular point in time. 90 decibels, if the sound's pitching at 90 decibels, then it's probably okay to be doing that at peak. And if the average is sitting around 80 to 85, it's less than what's going to cause permanent hearing loss over an 8-hour period, and that's what they say is generally safe. So there's one of the things that can be done if there's some questions in the congregation about sound, to use a decibel meter. Of course, the ones on a phone aren't so useful, but it is a way that we handle whether it's too loud or too soft.
They're not accurate as well.
They're not 100% accurate, yeah, that's right. And also the microphones that are being used are not broad spectrum microphones. This is just for instance, this is just a mobile phone. It's not doing a great deal, but that's something we can use there's levers on the board that would probably help to adjust that. Our system is what they call a sound reinforcement system, which means that it's not there to like a big massive rock and roll system where everything goes through the what we call the front of house speakers. It's actually just the front of house speakers are really just to promote the sounds that aren't coming up as strongly. And there's a third indicator here. Do you know what that is?
That's where we put the wires so people don't trip over them.
That's exactly right. There's tripping hazards right throughout the place. Just over here, I might just point one out. If we go over here, sorry. There's a tripping hazard here. That's the snake, and I've just put, for the time being, put something across it so that no one gets themselves hurt. And I'm using it to store the microphones because eventually we'll start using them. So they're the three key areas of workplace health and safety that I think are relevant to a sound system. Do you have any questions about the workplace health and safety factors here?
No, that's good.
This is an interesting challenge in itself, isn't it, this snake here? Because it is an inherent one that's sitting across the floor. It's probably the only one in the building. It is probably something over time that we need to look at and think about.
It's not a public walkway, only the
That's true.
sound desk is there.
But it's a possibility that there's challenges there. Okay, well, why don't we move on from there, since you know most about that sort of thing. Perhaps we could just talk through that. There are cables all over the place, for instance, on the chancel, the stage. What other sorts of things could we do to mitigate risk there? We've got one, for example, up near the lectern. It's a guard like this. Is there anything else we could do?
Well, we've done some cable tying of cables just to keep them coordinated and organised and together, so that they're not splaying in all directions.
Yep.
We make sure damaged cables get replaced.
Yep, that's a good one. Is there anything else we could do? Like, for instance, if there was a particular event and they needed cables running across the floor for extra lighting or extra sound, what else could we potentially do?
I use more of the cable hiders.
Possibly, yeah. I was thinking tape, gaffer tape is quite useful. Yeah, so a length of gaffer tape can be useful. And so, yeah, they're the three ways I guess we mitigate the risks of being too loud, too dangerous from an electricity perspective, and the tripping hazards, which of course are the major reason why there are insurance claims and workplace health and safety issues right around the country. Okay, let's move on from there and talk a little bit more about the sound system. Now, this is a little bit contrived, so bear with me, but I was trying to make it somewhat biblical. It's the Tigris-Euphrates river system. And I'm using this as a metaphor for the sound system. So a river is a stream, I guess, in a sense, and so is sound in a way. So the rains come down on the mountains of eastern Anatolia here in Turkey, and they run down gorges towards Syria and Iraq, northern Iraq, and then there are plains through which they sort of trickle their way right across the country. In particular, I think it's Iraq there. Yeah, it's Iraq there, Tigris and the Euphrates. And in these areas, they sort of splay out a bit. It's not all just one massive stream. And then towards the bottom here in Iraq, there's a what do you call it? There's a mouth, or the stream folds into one and heads out here into the Persian Gulf. And I'm trying to use this as an example. I don't know if it's perfect, but an example of a sound system. So if we considered the source up here is all the instruments, and the gorges are the way they get sort of channeled together, grouped together. The planes are kind of like, I'm using this loosely, an alternate place where water flows, and I'm trying to use that as an example for foldbacks. So the system that enables musicians specifically to hear themselves, exclusive of what comes forward, and then the stream or the mouth is these big speakers here, the front of house speakers. Can you think of any other analogies that might work with that? So here's the example here.
Yeah.
Can you think of anything else?
Not particularly.
I was thinking a plumbing system could be a little bit like it. I mean, I guess it's kind of very similar to or perhaps an electrical system of a house. You know, it's a little bit reverse though, isn't it? Because that comes from one line in and then goes out to many, many different areas, but it gives you the rough idea of where I'm trying. The sound system is essentially a river system. So from time to time I'll try and use those terms, but you know, I appreciate the
I get it as an analogy. It makes sense, yeah.
So we'll continue with that. This is and I want to give you this. I think this is useful. I've modified this from the Allen and Heath instruction manual on our sound desk. This looks a lot like our Allen and Heath 24 channel. This is just a 10 channel sample, and it gives you a visual of here's the instruments that we're just talking about, the source, and it also has these are kind of like these things here are probably what I'd call gorges. So they're actually this is not really a good example. There's not much in the way of gorges. Let's forget that. In terms of the planes, these particular knobs here are important. We'll get to them in a minute. They're called auxiliaries, which is the second way people hear the people, particularly at the front of the church. And then this here is like the mouth, the two main channels, and that's where the front of house system sends sound here into the front of house speakers. That's a subwoofer. We don't have one of those. And there, that's the foldbacks at the front here. It just gives you a visual of what's happening. There's different things can you see any differences of this system on the screen here too, from our current system? I guess from a technical perspective, perhaps it's a little bit not so important, but what sort of drum kit is that?
That's a acoustic drum kit, and we've got electric.
That's exactly right. So the electric drum kit is probably working a little bit more like the bass guitar here. So it's using a direct box. In fact, every single instrument other than the vocals are using a direct box.
Or a violin, if we have that.
Or a violin, that's right. That's actually but a violin's probably used more like a vocal. A vocal, yeah. Direct boxes are actually powered here. They're active boxes. They use phantom power, the 48 volts, to send from the stage back to the desk a balanced signal. So it has some similarities, but really it's just the microphones and the bass guitar are the two different main types of what we have here. But it gives you an indication as to how it works. I just wanted to go in this brief session. It hasn't taken less time than I thought. Just wanted to talk about the difference between the different types of instruments. So all instruments pretty much on the stage, apart from vocals, send high impedance signals into the desk. So
what does impedance mean?
It's the level of attenuate, or the level of electrical signal that goes into the desk. So they're sending a lot of electrical signal. That doesn't. It's the same as if it's electric powered or if it's even a passive pickup. They're still sending a lot of signal into the desk. Whereas a microphone is really using. If we have a look, let's go and have a look at a microphone. Sorry, I'll bring one over. It's not doing a great deal. It's relying on our voice to actually create electrical current using the magnets, electromagnetic field, to then send a signal over to the desk. So and it's not powered, so it's really what they call a low impedance device. So what we find is that any other instrument, apart from a microphone, needs to actually be regulated before it goes back to the sound desk, and that's why we use a direct box. They do that conversion from a high impedance to a low impedance. So you'll notice that these get plugged straight into those cables, whereas all other instruments don't. So I'll show you later with the guitar. But the drum kit is plugged into a DI, a direct inbox.
I've heard you guys use the phrase DI box, but I didn't know what it was.
Direct input. And it does that conversion of high to low impedance. And so, now I use the word snake because it kind of looks a bit like a Medusa's head, really, in a way. That's a whole bunch of, I can show the screen. It's got a whole bunch of these, what do you call them? Male and female connectors, and they're using a technology called XLR, which has been around for a long time, 3-pin, and one pin's hot, so it can run power through it, and the other two send that balance signal. And the reason why we do that too, you can run a guitar straight from over there to the desk, but the more length of cable you have with a high attenuation running, high impedance signal running through it, the more chance you have of picking up hum from other electrical instruments. So that's why we're using balanced signals. So the idea is that if a signal's sent on two cables and it cancels itself out, essentially, from an electrical interference perspective. I guess we don't really need to know a lot more than that, but that's what's happening with the snake. So the snake is an XLR. It's able to send power on a DC, which only requires one wire to do that. To this particular box, the direct input box, and that does a few features. It converts it uses the DC power, and it's also able to not only receive a high impedance signal, but it can actually even attenuate it further. So it drops a really strong signal. If it's a super strong signal, then it can actually drop down again and again. It's got two attenuators. It can drop 40 decibels of volume. So that's really the sum of our musical instrument system from a theoretical perspective. So we're talking about an overview. You got any questions about that?
No.
No, cool. All right. Well, I think it's fairly plain to see. What we're going to do in the next session is go through the elements of the system. We'll walk over there, do a fair bit of walking around, and just talking through some of its components. Let's just break from that.